Hello everyone, welcome back to CodeMaster. In today's video, we are diving into the linear search algorithm. This is one of the simplest and most fundamental algorithms in computer science, but understanding it deeply will help you build a solid foundation for more complex algorithms. We will break down step by step, covering how linear search works, its implementation, time complexity, and real-world applications. So let's get started. What is linear search? Linear search is a simple searching algorithm where we check each element in a list one by one until we find the target element or reach the end of the list. It's called linear because the number of comparisons grows linearly with the size of the list. So the key points to remember are: first, we start at the first element of the array, then we compare each element one by one with the target value, and if we found a match, we will return the index of that element. Otherwise, if no match is found, by the end of the array, we will return -1. For example, imagine you have a list of numbers 15, 23, 7, 42, 89, and 31, and you want to find the number 42. With linear search, you will start from the first element, check each one, and eventually find 42 at the index 3. Let's understand the key characteristics of linear search. It works on both sorted and unsorted data. Means you don't need to sort the data beforehand. You can search directly. Second point, can be implemented on arrays, list, and linked list. Linear search works on almost any linear data structure. Third point is best suited for small data sets. It means for small lists, the simplicity of linear search makes it a great choice. Next point is does not require pre-processing, which means unlike binary search, linear search doesn't need any preparation. The last point to remember is it is simple and easy to understand. Means the logic is straightforward, making it perfect for beginners. Now let's talk about the time complexity of linear search, which tells us how the algorithm performs as the input size grows. The best case is order of 1 if the target element is at the first position. We find it in one step. The worst case is order of n if the element is at the last position or not in the list at all. We have to search the entire array. The average case is order of n. On average, linear search will check half of the elements before finding the target. The space complexity is order of n. Linear search uses constant space because it only requires a few variables for iteration, regardless of the array size. Now, let's break down the algorithm step by step. First, we begin the search process. Then, we will input the array and target element. Then, we loop through each element of the array and we compare the current element with the target. That is the fourth step. If array of I equal to key. In this step, we will check if the current element matches the target. And in the fifth step, if a match is found, we will return the index. Next, if no match is found, we will return -1. Then we complete the search. Here is a clean pseudocode representation of the linear search algorithm. The loop starts at the index 0 and goes up to the last index. It compares each element with the target key. If it finds a match, it returns the index of the element. If no match is found, after checking all the elements, it returns -1. Let's see the Python code for linear search in action. So this is the Python implementation of the linear search. So we will define the function linear search. We will pass the array and key. Then for I in range length of array, if array of I equal to key, we will found the element, we will return the I, which is the index of the element. And after completing the loop, if the element is not found, we will return -1. That's how we can implement the linear search in Python. Let's trace the algorithm step by step with an example. For example, we need to check 42 in the list 15, 23, 7, 42, 89, and 31. So in the first step, we will be at index 0 and the element is 50. Since it doesn't match with 42, we will go to the next iteration. In step 2, the index is 1 and the element is 23, as you can see. And 23 is not matched with 42 and we will go to the next iteration. In the third step, the index is 2 and the element is 7. Since it doesn't match with 42, we will go to the next iteration. So in the fourth step, the index is 3 and the element is 42. Since 42 is matched with 42, we will return the index 3. Since 42 is present at the index 3. Linear search is useful in many situations. Searching in smaller datasets when data is unsorted, searching in data structures like linked list when elements are frequently added or removed. So these are the some of the use cases of linear search. So here are some practical examples of linear search. To find a contact in an unordered phone book, to look for an item in a grocery list, searching for a student in an attendance register, finding a specific file in an unorganized folder. Some of the advantages and disadvantages are, so the advantages include easy to implement, there is no complex logic needed, works on all types of lists, sorted or unsorted list. It doesn't matter, it works on all types of list. No additional memory is required. So some of the disadvantages are slow for larger dataset, it is inefficient for long list, not optimal compared to other search algorithms. So some alternative includes for sorted data, we can use binary search, which is order of log n, is much faster than linear search. This is the performance comparisons with linear search, binary search, and jump search. So for linear search, the best case is order of 1, worst case is order of n, and average case is order of n. It works on sorted as well as unsorted data. So next, binary search, it best case is order of 1, worst case is order of log n, average case is order of log n. It works only on sorted data and it doesn't work on unsorted data. Next is jump search. Its best case is order of 1, worst case is order of root n, and average case is also order of root n. It works only on sorted data and doesn't work on unsorted data. So in this video, we have learned the linear search basics. We have learned about the algorithm and how we can implement it in Python, the time and space complexity, and when to use linear search and real-world applications and comparison with other algorithms. In next video, we will learn about binary search, its detailed explanation, its implementation, and all thing. So if you found this video helpful, don't forget to like, share, and subscribe to CodeMaster for more coding tutorials. And see you in the next video. Happy coding.